Hi, my name is Chenebo Derek Owusu, and I will be your instructor for the complete course in C programming language for beginners. And I will urge partakers of this course to attentively engage in every aspect and practically try to write the code on their own, as it is the best form of understanding and studying the C language. I hope this course meets your understanding in the C language, and I wish you all the best in your studies. Now let's set the ball rolling. Now, in this course, we will be studying something about IDE. We will build our first C program. We will know the basic syntaxes. We will know the various data types. We will learn about variables. We will also learn about constants and literals. We will know the various storage classes. We will learn about operators. We would also be learning about how to make decisions. We will learn about iterations or loops. We will also be learning about functions, scope rules, arrays, pointers, strings. We will also be learning about input and output functions. You will know what preprocessors are, header files, typecasting, recursion, variable arguments, memory management, and last but not the least, command line argument. Now, a program is a set of instructions assigned to perform a specific functions. Therefore, a computer programming language is a medium through which a programmer interacts or communicates with a computer. In performing this, the programmer feeds the computer with sets of instructions to perform a specific functions. Now, C language is a general purpose programming language which is used for writing programs in operating systems, numerical computations, graphic applications, and many more. Now, when a programmer gives sets of instructions to the computer, translations are being done by special softwares called IDE, which makes the computer to understand the given instructions. Hi, in the introductory part of our course, we learned that the programmer gives instructions to the computer, and then specially made softwares translate this program or instructions to an understandable language to the computer. Now, let's learn about IDE. IDE stands for Integrated Development Environment. They are specially built softwares that assist in writing, editing, compiling, and executing the program of a particular language. Examples of IDEs are CodeBlocks, NetBeans, Anguta, CodeLite, Dev C++, Turbo C++, and many more. But in this course, we will be using CodeBlocks, and then CodeBlocks can be obtained freely on their website www.codeblocks.org/download. And after successfully downloading your CodeBlocks, we will start to build our first C program after we have launched our CodeBlocks. So let's try to build our first C program using our CodeBlocks. But also you can also try with other IDEs of your choice, but I will be dealing with CodeBlocks. So let's begin our first C program. Now, we have successfully launched our code blocks. So let's try to build our first C program. So we click on new project, then we go to console application, we double click that, then we click next. As we are dealing with C, let's select C and then we click next. Let's give the project a title. So let's title this project as C language. C language, and then we click next. Then the compiler will be GNU/GCC compiler. So let's click finish. Okay. So let's begin to build our first C program. From this workspace, we can see the project title over here. You can see our project title over here. So we can see our project title over here, and then under it we can see sources. So under sources, just double click on sources. We can see main.c, then we click on main.c, and then we have been given our main. So this is our first C program. So let's try to type them by ourselves so that we can be able to understand every part of it. So first of all, hash include stdio.h int main then printf, bring our double quotations, then let's type hello world. Okay, a semicolon. So let's try to run this program and see the outcome. It seems that this project has not been built yet. Do you want to build it now? Yes. Should have built it before running. Sorry for the delay, because we should have build it and run it, but we were rather so our program has been built successfully. So this is our program. It has been built successfully. Hello world has been printed. Okay, so we press any key, it goes. Okay, thank you very much. This is our first C program which has been built successfully. Please kindly try to compile it, write the program and compile it yourself. Let's see. Hi, in our previous lesson we learned about how to build our first C program, and our program was in the form of this: hash include <sign stdio.h int main bracket braces /. This is my first C program, printf hello world. semicolon, return 0 semicolon. Now the first line include stdio.h is called a preprocessor. This is called a preprocessor. This is telling us that we are including a header file called stdio. Now, which is a header file. So stdio.h becomes our header file. It is our header file, hence .h. We will learn about that very soon. And then int main in brackets is the main function from where execution will begin. The next line, the double slash, is also used to comment on programs, or it enables the reader to understand what the programmer is doing. Therefore, they are being ignored during execution. Now, let's learn something about basic syntax. Remember, syntax is the laid down procedures for writing a statement. They are also called the formulas for writing a statement. So, in every formula, you can't maneuver or jump from one to another unless you follow the laid down procedures before you can write a program in C. So the procedures that we follow is called syntax. Now let's learn something about tokens. Tokens consist of either a keyword, an identifier, a constant, string, or a symbol. For instance, printf, bracket, double quote, hello world. The individual tokens are 1. printf, 2. the open bracket, 3. hello world, 4. closing bracket, and 5. semicolon. These are various tokens before we can, write a program for this. These are the various or the individual tokens we have in this. Now, the semicolon that we saw is used in programming when we want to terminate or end a statement. That is why we have this semicolon here. After we build our first program, we terminated it with this semicolon. So it enables the program on which one is writing to end. Now, we have ways of giving comments on the program that the programmer is building. And in as much as the programmer is writing it for himself, the reader, in order to understand what the programmer is doing, the program will have to indicate this or that. So this one also will be ignored during execution. So we will try our hands on that one and then see them once again. We also have identifiers, which is used to identify a variable, function, or user-defined items. They start with letters A to Z in block letters or A to Z in small letters, and numbers and underscores. Examples: Nana, Luku, busy underscore bone, Derek 399, item 34, and etc. etc. We also have keywords. Keywords are inbuilt words in C language. There are 32 keywords in C. Remember, keywords cannot be used as a variable. For instance, we have keywords like auto, break, long, switch, return, static, void, long, while, and many more. The user cannot use any of these keywords as a variable. We'll learn about variables later. We also have something called white spaces. It's a blank space that separates two elements. For instance, int white space main. We have a space between the int and main. So that one is differentiating between these two elements, int and main. So white spaces help the compiler to be able to differentiate between int and main. But let's take a look at vehicle is equal to BMW plus Toyota. Remember, there is no white space in them. They are all classified as a single statement. So there is no white space between them. Now let's get back to our program that we built and see something. Hi. In our previous lesson, we learned about how to build our first C program, and then we can see that our first C program was in a form of this. Hash include stdio.h. We place our comment over here, and then int main, and then braces printf hello world semicolon. Now in this, as far as this is concerned, before our program was being built, it followed something called a syntax. Now a syntax or basic syntax is the lay down procedures for writing a statement. They are also called the formulas for writing a statement. So therefore, you can't ignore the formulas before you can reach your target or your aim. That is why we quoted this hash include stdio int main braces and then printf hello world before this single hello world was being printed, as we saw from our first program that we built. So the various or the lay down procedures for writing a statement is called a syntax. Let us also learn something about tokens. Now, tokens consist of either a keyword, an identifier, a constant, string, or a symbol. For instance, the individual tokens for printing or maybe programming hello world are we have printf here 1, we have this open bracket 2, this whole thing in quotation 3, we also have closing bracket, we have our semicolon, we have closing brace, opening brace, int main, open and then closing bracket. They are all tokens. So as far as token or the syntaxes are concerned, these are our various tokens and then which are being combined in order to follow the syntax. in order to form a syntax. Okay, now let's go to the various tokens which were involved in the syntax. Now, we have semicolons. Semicolons are being used to terminate a statement. So every statement that you write must be ended by semicolon to show a termination. Other than that, when you neglect semicolon, your program cannot be run. Okay. We also have the double slash or a single slash with a star symbol and then a star with a closing slash, which are also used for commenting. So when you want to help the reader to know what exactly you are doing, you just indicate them by a double slash and then write the comment so that the reader would understand or know what you are about. That is why in our program that we built, we had something like this. Something like this is the same as also this one. They are all the same. So you can either use this or that. Now let's learn something about identifiers. An identifier is used to identify a variable, function, or user-defined items. They start with letters capital A to capital Z or small a to small z, or numbers and underscores. Example, you can have a user-defined name like this one, Nana, Duku, busy underscore bone, Derek 399, item 34, etc. They are all identifiers. Let's also learn something about keywords. They are inbuilt words in C language. They are inbuilt words in C language. We have 32 keywords in C languages. Remember, keywords cannot be used as a variable. So the keywords that are being made or that has been built in C language cannot be used as a variable. Example of such keywords, we have auto, break, long, switch, return, static, void, long, while, and many more. You can't use any of these words or keywords as a user defined or as a variable. Okay. Now let's also learn something about white spaces. White spaces is a blank space that separates two elements. For instance, when you have something like int and then space main, they are not the same because they are being separated by a space which is called a white space. Okay. Remember, when you have something like vehicle is equal to BMW plus Toyota, there's no white space in them, so it's a single statement. It's a single statement. Now let's learn something about constant and literals. They are values that cannot be changed in the program. Now, when you assign a value, or maybe let's assume you assign an integer value or a float or a car, in the course of building the program, you cannot change the constant. You cannot change the constant. It will remain as it is throughout the program. Now let's learn about ways of defining constants. We can either use the hash define preprocessor to define a constant, and then we can also use using the constant keywords to define a constant. Example 1. Now you can either write something like this. You write the keyword const, then float sp is equal to 3.142. Now sp value cannot be changed. The value for this one, once it has been assigned as constant, it cannot be changed in the course of our process. So let's try to build this program and see. Let's try to build this in our code block and see. Okay, now let's build a program to see the constant assigned values. So let's include our stdio for standard input output header file. Let's also include connew, then int main, then let's call our braces. So the constant float for sp is equal to 3.142, then our semicolon. So printf quotation, the value of pi is percentage f for float value with respect to sp. So let's run this program and see the outcome. Okay. Now the value of pi is 3.142, as we can see. The value is 3.142 because it was assigned to be a constant. So let's try to change the value over here and see what we will get. Okay, let's change the value of sp. So let's say float sp is equal to 399. So let's run and see the outcome. Okay. Okay, so you can see it's still giving me error over here. You can see it's still giving error. Conflicting type qualifiers for sp. Okay. So we can see that after we assign this speed, which is equal to 3.142, to be constant. So now that we change it over here and then we started to run it, you can see it was giving us error. You see, so this is how constant, once being assigned, it cannot be changed in the course of the. Okay, now let's build a program, to conform with the constants that we just learned. So let's open a new project, console application, next project title, constants. Next. Okay, now this program will find volume of a sphere object. Okay, so let's include stdio.h. Let's include conio. Then let's begin the main, from where our function will begin. So float volume radius, and then constant float for pi is equal to 3.142. So printf enter the radius of the sphere object. Enter the sphere of the sphere object, scanf. Now scanf is used to read numbers or variables from the reader. So you continue to apply them and then you understand every bit of it. So %f address of radius. So volume is equal to 4.0 divided by 3.0 by radius by radius. Let's print the volume of the sphere equal to percentage f with respect to volume. So let's build this program and run and see. Sorry. Oh, come on. Okay. Enter the radius of the sphere object. So let's assume the radius of the sphere object is maybe 6. So the volume of the sphere is 288. So this is the volume of the sphere with a radius of 6. Okay, now let's find another radius of a sphere object. Now let's assume the radius is also maybe 12. The volume of the sphere is 2304. So as far as constant is concerned, it can never be changed in the course of process once it's been defined. So this is how constant is being applied here. Hi, in this topic we will be learning about data types. A data type is a way in which variables are being declared, and then we can also say that data types are mainly used to allocate the memory. Now when we declare variables of any valid data, then the computer allocates some fixed size of memory. Now the major or the basic data types are integer, float, and char. And char has a size of 1 byte and a value of -128 to 127 with the format %C. Integer also has 2 bytes or 4 bytes with a value of -32768 to 32767 with a format of %D. We also have unsigned integer and then signed integer. We also have signed and unsigned character, etc. And then we also have float for all decimal numbers. Now, let's continue. As we have learned about data types and sizes which they occupy in the memory, let's continue. Now, one may ask, what is a preprocessor or what are preprocessors? It's a simple macro processor that conceptually processes the source text of a C program. It is controlled by a special command line which begins with character hash. Lines which do not contain hash lines are called the program text. Now, what is a preprocessor? A preprocessor is a simple macro processor that conceptually processes the source text of a C program. It is controlled by a special command line What is a preprocessor? A preprocessor is a simple macro processor that conceptually processes the source text of a C program. It is controlled by special command line which begins with character hash. Also, preprocessor is a keyword or statement which informs the compiler to make additional changes or modification in a program. So it begins with hash symbol. It begins with the hash symbol. Though let's look at some of the uses of preprocessor. They are used for including files, especially header files. And then, for instance, you can use it hash include, then followed by the less than and then greater than sign or quotation. Also, for defining symbolic constant through the define command, hash define command. So you can define something like define SP 3.242. You can also use the preprocessor to define maybe hash error, hash define, hash if, hash and if, and so many and so much more. So as we continue with our program, you will see we'll be applying them in the program. Remember, it always include a header file. It always include a header file, or it is used to define maybe a symbolic constant. Now, let's learn something about header files. A header file is a file with extension .h which contains C function declaration to be shared between several source files. Header file is a file with extension .h which contains C function declaration to be shared between several source files. We have inbuilt header files and user-defined files. Let's go back to our program and then look at some of the header files. So, header files, this is a header file. This is a header file. So, with the work or with the help of this preprocessor, it is helping us to include a header file called stdio. We also have header files like conio, string, and so many more, std, lib, std library for the full name, and so many more. So as we go on with our program, we will learn about the header files, and then we'll be applying them in the case of our program building. Hi, in this section we are going to learn something about storage class. Now, what is a storage, one may ask? Storage class specifies the storage location of a variable in the computer memory. That's its value, scope, and then its lifespan. Simply put, you can see that storage shows the visibility and the lifetime of a function. Basically, there are four main types of storage class, which they are auto, register, static, and extend. Now, auto storage is the default storage for all local variables. It stores the variable in the random access memory, the RAM, and then its scope is a function. Scope here is referring to as the visibility of the variable. So when you see the variable, you can see it as a function in the auto storage class. Register also stores the variable in the CPU, that's the central processing unit. The default initial value is a garbage value, and then it has a visibility of a function. Static here stores the variable in the RAM, that's the random access memory. The default initial value is 0. It has a scope or visibility of a function. Extend also stores in the RAM. It has an initial default value of 0, and then okay, now we are going to build a program in support of our various storage class. So now let's open our code block, create new project, console application, next, C, next, project title. Let's name this project as storage, and then next, finish. Okay, so let's go to the source and then use main.c. Okay, so let's clean everything and then let's start afresh. So first of all, let's include stdio.h, and then but sorry, let's give the program a title first before we can. Now, so this program will display storage class. Okay, now let's include our stdio. each header file, and then nothing will be returned. So void let's learn something about auto. So maybe variable, auto variable, var underscore auto, then let's call our brackets and semicolon. Okay, so void avoid main here refers to that nothing will be returned. So let's give maybe integer x is equal to, let's assume 10, our semicolon, and then we printf. Let's printf x is equal to the percentage d with respect to x. Okay, so var underscore auto or auto variable and we call our bracket, and then void var underscore auto bracket, integer x is equal to maybe 20, printf and x is equal to percentage d with respect to x. Okay, so now let's run this program and then see the result. Sorry, I left my semicolon. Okay. Now we can see from here that, let's take a good look. Now we can see that from here the variable or auto variable which was assigned over here, x is equal to 10. So that is why it displayed x first, which is the auto, that's the default number or the default variable x here before it printed this number here. So all the time the default or the initial number would be displayed first, and that is the auto. So take note of this. Okay, now we are building a program to demonstrate our register storage class. So after you've included our standard input output header file, let's return nothing, void and then let's assign a variable register. So void main is where our function is beginning. So since we are beginning the function from main, let's call our braces and then assign register integer x is equal to 5, printf x is equal to percentage d with respect to x var underscore reg then var underscore reg void var underscore reg, then we assign another function under the variable register. So register integer x is equal to 5, and then let's give a function x is equal to x plus 2. So let's print the value of x is equal to percentage d with respect to x. Always remember to terminate your program by a semicolon. Without semicolon, it makes your product or a program not terminated. So always remember to take note of that. Let's go and run this program and see the outcome. Okay, good. We can see that when we assign a value for register, the initial value, which happens to be 5, will be printed first, and then the preceding ones also follows and then reaches a maximum or displays an equal value of numbers after the initial value. So that is how register, once we register a number in a storage class, that is how it operates. Okay. Okay, now we are going to build a program to demonstrate our external storage class. So we open a new project, console application, and then let's give this title extend storage. Okay, so let me save this. It's already in Udemy. Okay, and we finish. We click finish. So now let's go to the source, the main, and then let's clean everything so that we can start. We including a stdio.h header file, and then let's assign an integer value x is equal to 5. Then you will not be returning anything, so void, then variable var underscore extend, and we call our bracket semicolon. Now this is from here where our main or our function is beginning. Then we call our braces. So var underscore extend, we call it once again, and then x is equal to x plus 1. We are assigning some values for x, which is an integer, so we are increasing the value plus 1. So let's print f the value of x is equal to percentage d with respect to x, var underscore extend. Always remember to call your semicolon to terminate the process, or else you will have difficulty running the program. So void var underscore extend, so it's also beginning another function, x is equal to x plus 1, then our semicolon, print f x is equal to percentage d with respect to x. So let's run this program and see the outcome. Okay, now we can see that with the external or the global storage, the initial value that we assigned is always not declared, but rather it starts the declaration by increasing the value first, and then it keeps on increasing it. That is why we have an integer x which is equal to 5, but once we assign it globally, it increased it before printing it, and then thereby started increasing it again. That is why we have 6, 7, 8. So that is how our global storage behaves. Now, in this topic, we are going to learn something about operators. An operator is a symbol that tells the compiler to perform a specific mathematical or logical manipulations. An operator is a symbol that tells the compiler to perform specific mathematical or logical manipulations. Types of operators are: we have arithmetic operators, relational operators, logical operators, assignment operators, incremental or decremental operators, and many more. Now let's learn something about arithmetic operators. Arithmetic operators are binary operators which are used to perform arithmetic operations. So this symbol over here is a symbol of addition. This is a symbol of subtraction. This is a symbol of multiplication, division, and then when you want to find the remainder of a number, this percentage sign here is called modulus, which is used to find the remainder of a number. So let's build a program to find out how arithmetic operators operate. Okay, now we are performing some basic arithmetic operations. So we have an integer value of a is equal to 21, integer b is equal to 10, and then we don't have any value for c, but we are declaring c as a variable. And then we can perform an operation of c is equal to a plus b, whereby we are adding the value of a and b in order to replace c. So c is equal to a plus b, semicolon, printf, the value of c is percentage d with respect to c. Okay, so let's go and run this program and see. Okay, the value of c is 31. The value of c is 31. So you can see that when you add 21 and then 10, you will have a value of 31, 31, sorry. Okay, in the same manner, let's change the values of the operand operator plus, and then let's use minus, and then we are subtracting 10 from 21. So let's build and run this one also and then see the outcome. Okay, we can see that the value of c is 11, because when you deduct 10 from 21, you get the final answer of 11. Okay, so now let's change the operator and then use multiplication. Okay, so we are multiplying 10 and 21. So let's build and run this one also. Okay, the value of c is 21. So it's as simple as that. Now let's try to divide a over b. Now what will happen here is, when you, in the first place, let's build and run the program and see the outcome. Okay, it is giving us a value of 2. c is 2. c is 2. This is because when you when we divide 21 by 10, it will give us a decimal value or a float value. So in order to get a float value, we have to convert or typecast this c here into a float value before we can get our answer to be a decimal or a float value. So let's go and run the program and see. Okay, let's convert all these values into float values. So float A is equal to 21.0, and then float B is equal to 10.0. So let's go and run this program and see that. Okay, we are getting a value of minus 10 point something something something. Okay, yeah, so this is how it is. Now let's find the remainder percentage. Remember, the modulus or the remainder is always noted by percentage. So let's go there and run it. So let's convert this into integer values. So we can have our integer values. So let's rebuild the program and then see the outcome. Okay, so we can have a remainder of 1, because when you divide 21 by 10, there will be a remainder of 1. So this is how operators work in C programming. Okay, there can be instances whereby we will be reading values from the user. So in this case, what we will do is we assign some two values, say A, B, and then maybe we are finding the sum value, so let's assign sum to be an integer. So let's print F to display the option for the user. So enter the two variables. Then we use scanf, which is used to read content variable from the user, percentage %d, percentage d, percentage d. Percentage d with respect to the address of A, address of B. Now the address over here is assigning this percentage d to this value, and then percentage d to this b value. Okay, so sum that we are already assigned to be an integer is equal to a plus b. So printf sum of the sum of a and b is a semicolon. So let's go and run this program and see that. Okay, so it says enter the two variables. So let's assume I assign 1, 2, 3 as the first variable, and then the second variable to be 23. Oh, sorry. I should have, assigned the percentage sign d, percentage d with respect to sum. Okay, now let's build it once again. Run it. Okay, enter two variables. So I'm entering 1, 2, 3, and then 2, 3. So the sum of a and b is 146. So this is how it is. In the same way, if you want to maybe find or read variables to find a difference or to subtract, in the same way we can change this with subtract, and then assign the subtract over here to be subtract is equal to a minus b. So the subtraction of a and b is percentage of d respect to subtract. Okay, so let's go and run this one also. Okay, enter two numbers. Let's assume I enter 9. I enter another number to be 3. So the subtraction of a and b is 6. So it's as simple as that. So always take note of that. Okay, now let's go to the relational operators. These operators are used to compare two variables or values. These are mainly binary operators. And then the result of relational operators are either true or false. So the numbers or the symbols used in relational operators for comparisons are the greater than sign, less than sign, less or equal sign, greater or less sign, equal to sign, and then not equal to sign. So let's perform let's build a program, to demonstrate some relational operators. So we would include a standard input output header file, and then our main function begins. So let's assign an integer value. A is equal to, say, 21. B is equal to, is also an integer value, so B is equal to 10. So if this is where the comparison begins, if A is equal to B, then print A if A is equal to B, then print the statement is true. The statement is true, but we can see that A here is not equal to B. So let's build this program and see what we get. So I left my semicolon. Okay, let's build this program. So nothing was returned. Okay. So let's assume A is greater than B. So if we know that A is greater than B, then let's print A is greater than B. So let's print the outcome. Okay, so you can see A is greater than B. So in instances whereby okay, so let's assign another value, C. Now C is equal to A is less than B. let's print the outcome. The value of C is percentage D with respect to C. So let's find out the outcome. Okay, now it is giving us 0 because A is greater than B. Okay, so in instances whereby it becomes true, it will give us an answer of 1. So let's change this operator sign and then see. Okay, so we can see that the value of C is 1. Okay, now let's go to assignment operators. Assignment operators are also binary operators which are used to assign values to a variable, and then we can write a program in this form. You can write a program in this form. B plus A B plus is equal to A. So let's find the value of this. Okay, so let's print the outcome. So we've already, let's assume we've only assigned A to be 21, then B, we don't have any value for B. So now B plus is equal to A. So let's find the value of B. We print off the value of B is equal to B is equal to percentage D with respect to B. So let's terminate the process. Okay, so let's go and run this program and see the outcome. Okay, the value of B is 110. Why? Because the increasing value of B of A is equal to 21. Is equal to 21. Is equal to 21. In the same way, when we change the value of, or the operator, this build and run it, we can have a value of 68 in the outcome, because this this Hi, in this topic we are going to learn something about decision making. Now, decision making is whereby the programmer issues a condition, tests it, and when it is positive or negative, set of statements are being executed. And under decision makings we have the if statement, if else statement, switch statement, nested. And so we are going to learn something about the if statement. With the if statement, is when a statement is evaluated to either true or false, the block of code will get executed. Any non-zero values are assumed to be true, and all, or if it is either 0 or null, then it is assumed as false. Let us go to our code block and then see how if statement do behave. Okay, so assuming we assign some integer values, a is equal to 48, b is equal to 45, then we can say that a is greater than b. So over here this statement is true. So what we do is we assign a condition that if into bracket a is greater than b, then we will print a is greater than b. So let's print this statement, let's execute this statement and see the outcome. Okay, so we can see from here that a is greater than b, because a is 48 and b is 45. Okay, in the same way, when we have something like, let's change the values. Let's change the values and then print the outcome and see. Okay, nothing got executed because our statement is false. So therefore, nothing was being executed. Okay, so this is how the statement behaved. Okay, so let's put a is less than b and then let's execute it and see the outcome. Okay, a is less than b, but as the statement tends to be true, we will have a printing like a is less than b. So once more let's print it and see the outcome. Okay, so we can see that a is less than b, so it means our statement is true. So this is how the if statement operates. This is how the if statement operates. Okay, now let's go to the if else statement. Now with the if else statement, if the condition is true, set of instructions inside the if block will get executed. In the same way, if the condition happens to be false, set of instructions inside the else block will also get executed. Now let's go back to our code block and then see what we are talking about. Now, for instance, if we enter maybe a number as we have already done it with the if statement, and then the number happens to be let's assume, as we did already, let's assume I enter maybe 3, and then the number is positive. Okay, as it has displayed it to be a positive number, we can also write something like, if a is greater than 0, print the number is positive. Then we come here and then type else, print the number is negative. So okay, so let's execute this program and then see the outcome. Let's clean this. And then okay, so if I enter maybe 34, you say the number is positive. Good. And then in the same way, with the same program, if I enter maybe minus 98, the number is negative. So this is how the if else statement also behaves. So in the other way, if I enter a number which is greater than 0, it will display the number is positive. But when I also enter something which is false or is not up to the condition over here, then it will rather print this statement. So this is how the if else statement also behaves. Okay, in continuation of the if else statement, now we have built a program here to show the grade of students. Now, assuming let's assign the mark of the student to be M, and then the pass mark is 50. So when the student have 50, it means the student have passed. But when the student have something less than 50, the student has failed. So what we do is we enter integer M and then print F, enter the mark of the student to display it on the screen, then scan F to read the mark from the user. So we give a condition using the if statement that if M is less than 50, then print student failed. Else, if M is greater than 50, print student pass. So let's run this program and see the outcome. Okay, enter the mark of the student. Now, so let's assume I enter 71. I press enter. It said the student passed. Okay, in the same way, let me enter 24 or 23. I press enter. So you can see here that the student failed. So anytime we are using the if else statement, we have to issue a condition over here, and then when the condition is true, it will print it. When the condition is false, we will use the else if or if else statement, to print the negative or the non-true statement. So this is how the if else statement also is. Hi, in this topic we are going to learn something about functions. Now, a function is a piece of code or block of codes used in performing a specific task. C language has only one function, and that is the main that we've already been learning or we've learned about so far. Now, types of functions are, we have library functions, and then we have the user defined functions. What are library functions? Library functions are inbuilt functions that are contained in the header files. So as we can see, when we include the header file, we can use or we see some library functions such as printf, scanf, exit, strcpy, sqrt for square root, and many more. They are all library functions. And then when we talk about user defined functions, they are also functions that are being declared by the user or the programmer. Now, when we are defining a function, we have for instance, let's take a good look at this one. When we have return underscore type, and then we have function underscore name, they are called parameter list. They are parameter list. And then what is contained in the braces is called the body of the function. So in defining a function or definition of a function, we have return type, function name, parameter, and then we have function of a body. So let's look at the return type. A function may return a value. The return underscore type is a data type of the value that the function returns. So some functions perform the desired operations without returning a value. In this case, the return underscore type is the keyword for void. The keyword void. So as far as void is concerned, it means nothing will be returned. Okay, now let's also go to function name. This is the actual name of the function. The function name and the parameter list together constitute the function signature. Parameter. A parameter is like a placeholder or maybe an address of a variable. So when a function is invoked, you pass a value to the parameter. This value is referred to as actual parameter or argument. The parameter list refers to the type, order, and number of the parameters of a function. Parameters are optional, that is, a function may contain no parameters. So take note of that. And then function of a body. The function body contains a collection of statements that define what the function does. Okay. So now let's learn something about function declaration. For the compiler to know about a function name and how to call it, we use the function declaration to perform this task. So in performing this task, categorically we have the call by function and then function by argument. So let's learn about call by function. When a function is being called to perform a specific task, parameters are passed along with the function name, and if function returns a value, then you can store the return value. Once again, when a function is being called to perform a specific task, parameters are passed along with the function name, and if function returns a value, then you can store the return value. So let's build a program on this, so that we can understand what we're talking about. Okay, now provided we have let's have a program, and then this let's give this program a title. This program explains function or explains call by function. Okay, so over here we are including this stdio header file, and then let's assign some integer values. So with these integer values we will be finding the maximum number. So we will be finding the maximum number, so thereby assigning two integer values, number 1 and then number 2. So our main function begins over here. So over here we are assigning integer a, which is equal to 5, and b, which is equal to 12, and then the return value will be equal to maximum, which is a, and then b. So let's print the value of the return, which is the number. So the number, since we don't know the maximum number and then we assign two integer values, what we will get over here, what will be returned, therefore will be in place of the first numbers that we assigned over here, that the integer number 1 and the integer number 2 over here, and then the result will be if the number is greater than if number 1 is greater than number 2, then the result will be equal to number 1. Else if the number 1 is less than 2, then it will display the number 2 over here, and then we get our maximum number or maximum value being returned. So let's build this program and see. Let's build a runner. Sorry, could not read, please. Okay, so we can see that maximum value is 12. The maximum value is 12 because 12 is greater than 5. So we can boldly say that this explains, or this function is being called by function because we assign a specific function, and then the outcome that we had, or the number that we had over here, was being called into another function before it returned the value. So that is it for call by function. Okay, previously we learned something about call by value function. So this one we are also going to learn something about function by call by reference. So this program will help us, to find a cube of a number using call by reference function. So call by reference function, this method copies the address of an argument into the former parameter. In the function, the address is used to access the actual argument used in the call. So therefore, changes made to the parameter affect the passed argument. So let's run this program, and then afterwards we can explain it. So let's, after including our stdio header file, void cube integer pointer b. You already know something about pointer, so integer main, that is where our function is beginning. So let's assign an integer value number which is equal to 3, and then cube with respect to the number. Printf, the cube of the number is percentage d, number return 0, void cube is equal to integer pointer b. So we can see that the number here is pointing to b. It's pointing to b, and so therefore we are finding the cube of 3. We are finding the cube of 3. So void cube integer pointer b. This over here we are also getting a different function. So you can see that this function is a different function, and then this is also a different function. So let's we forget, pointer b is equal to pointer b times pointer b times pointer b times pointer b, because cube means the 3 times, or the product of the number times the product of the number times the product of the number, because cube is referring to the number in 3 full. So let's run this program and see the outcome. Okay, the cube of the number is 27. Fine. Why are we getting 27? You can see that there has been no changes in the values that had been we can see that there has been no changes in the values, because the numbers that were assigned weren't affected, but it was only the function that we called. It's only the changes that were being made. So you can see that if there will be any changes, it doesn't affect the value, but rather it is inside the function that the changes occurs. So that is all about function. Okay, now that we learned something about call by function, let's go to function by argument. Now, if a function is using arguments, there must be a variable declaration that accepts the value of the argument. So we have, under function by argument, we have function by call value, and then function by, or function call by reference. So let's take them one after the other. Then let's build a program to understand the call by value function and then call by reference function. Okay, in this program we already assigned some 2 integers a and b. This program will define function to swap values, and then we are assigning 2 integer values a and b. We are using void swap because void means we are not returning anything, nothing will be returned, and so swap here meaning we are interchanging the values, or the integer values that will be assigned. So let's assume integer temperature, and then temperature is equal to a, A is equal to B and B is equal to maybe temperature, we can boldly say that we have interchanged or swap the various variables. So therefore temperature becomes or is equal to A. We have replaced temperature by A, and then A is equal to B, and then B is equal to temperature. So we can say that A is equal to B is equal to temperature. From here we have swap or interchange the variables, and then hence they are all the same. So from here our function begins. So let's assign two integers. So number 1, which is equal to 5, number 2, which is equal to 12. So printf, and then let's print before swapping. Number 1 is percentage d, number 2 percentage d with respect to number 1 and 2, and then let's swap the numbers. So swap number 1, number 2. So print after swapping, number 1 is to percentage d, number 2 is to percentage d with respect to number 2 and then number 1. So carefully check from here. You can see that here before we were swapping, we swapped number 1 and then number 2. We printed it before it were being swapped over here. That is why here number 2, from here number 1 became number 2 over here after swapping them, and then number 2 also became number 1 over here. So let's print or let's run this program and see. Okay, so we can see that before swapping, number 1 was 5 and then number 2 was 12, as we can see from here. Number 1 was 5 and then number 2 was 12, and then after we swap the numbers, after swapping, we can see that number 1 became 12 and then number 2 became 5. That is function by call value. So that is it. Hi, in this topic we are going to learn something about arrays. An array is used to store multiple values which belongs to the same data type. Instead of declaring the individual variables such as number 0, number 1, number 2, number 3, 2, number 9, you can declare an array variable like numbers and use number in square brackets 0, number square bracket 1 to 9 to represent the individual variables. So let's explain this with a diagram. Okay, so now we can see that we have a table of numbers or array. They all belong to the same data type. So over here, what are contained in this storage locations are called the element. They are called the element. So they are called element. So over here, the first element here is the first element, and then what we have at the ending here becomes our last element. Okay, now let's go to this table also, table 2, and see. we have a table for storing pin numbers or an array of pin numbers. So in the first element, which is a size of 0, what we have in that storage area is 100, and then over here we have a storage location of 105, and then we have 110, then 115, 120 in the last element, which is pin with size of 4. Okay, so over here we can see that this pin here becomes or is the array name. So this pin name here is the array name, and then the 0, 1, 2, 3, 4 here are the index. They are called the indexes. That is the 0, 1, 2, 3. So all the indexes, they start from 0 and then end to the last element. So they are called the index. And then the pin square bracket 0, pin square bracket 1, they are all the array or the array elements. Okay, so we'll build a program to explain more on arrays. So we are building a program that will read the array size from the user, read and then display the highest number. So we included a standard input output header file, and then we assigned an integer value for n, which is the size of the array, and then number for the various elements that will be displayed, and then the highest number, which is a float. So we read something from the user, and then we issue the loop over here. So here is declaration of array size to n. Okay, then we issue the loop over here, whereby our number was equated to 0 but is less than the size of the array, and then we found the incremental value of the number, and then we also display the number and then read another value from the user, whereby the number becomes the size of that value that the user entered. And so we issued another loop. We issued a highest, which is equal to the values with the size of 0. So we issued a for loop, then the number is equal to 1 but is less than the size of the array, then incremental value of the number. Then also we issued another if loop, whereby all the values with the size of the number, size being the number being greater than the highest number, and so therefore highest value is equal to the values, highest is equal to values with the size being equal to the number. So we are displaying the number to a decimal. So over here is the end of the if block. Then here is also end of loop block. Okay, so let's compile and execute this program. Okay, so we said we should enter the size of the array. So let's enter maybe a size of maybe 8. Okay, and then the values, we have 20. So if you have a size of 8 and then the value is 20, then the highest value will be 1, negative 1. Okay, negative 1. So let's display it over here and then see. Okay, so that we can easily understand that one. So a size of 8 and then maybe 20. Yeah, so it's displaying a scientific number, and then that is that. Okay. Okay, we are building another program. We are building another program for array that would read size of array from the user and then print the highest value. So array 2. Okay. Okay. So a program that reads array size from the user and prints the highest value. The highest value. Okay. Let's include the stdio header file. Our main function. So let's assign an integer n and then number, and then float value for the highest number, float value for highest. Okay, so let's print it. Enter the array size. Enter the array size. enter the array size. Okay, so scan F. Scan F, percentage D with respect to address N. Okay, now let's declare array size with a size N. So float value N, which is the array size. So let's initialize some numbers. So for number is equal to 0, and then num is less than N, which is the array size, and then num incremental value. Okay, so let's use the if block or if chain block. So if value value square bracket count is greater than highest, then highest also is equal to value square bracket number, then so let's print F highest value is equal to percentage dot 2F with respect to highest. Okay, so what we just did is over here we assign some numbers, integer numbers, whereby the N is the array size and the number is the element or the variable, and then float value for highest, which is the number or the highest value that you will be finding. And so over here we read something from the user, or we read the array size from the user, and then here also we declare an array with size of N. So declaration of array size N. Okay, declaration of array size N. And so we use the for loop to build a loop. So under the for loop we had an if. So the if loop had this end over here. So here is the end of the end of if loop, or end of if block, and then here is also end of the for block. Okay, so let's compile and execute this program and see what we get. Okay, so let's build a program to initialize an array size of 10. Okay, so we include our st header file, int main. Okay, braces. So let's assign an array and with a size of 10, and then an integer I j. Okay, so now let's initialize each element of an array n to 0. So for I is equal to 0, I is less than the array size, which is 10, and then I increasing value, incremental value for I. Okay, so n is n to I will be equal to I plus 100, whereby we are setting each element at a location I to I plus 100. So over here, set a location for let's set a location at I to I plus 100. Okay, so let's go to j also. Let's go to j also. So for j is equal to 0, and then j is less than 10, so incremental value for j. So print f element square bracket percentage d is equal to percentage d. Okay, so with respect to j and n square bracket j. Okay, sorry. So what we did is we assigned an array size of 10, and then thereby assigning also an integer variables I and j. So over here we initialize element of an array. Initialize element of array n to 0. Okay, we initialize element of an array n to 0, and then thereby n over here for I is equal to 0, I is less than the array size n, and then I incremental value. That is why we have n square bracket I is equal to I plus 100. That is setting a location at I to I plus 100, and then for j is equal to 0, j is less than 10, and then j incremental value. So let's run this program and then see the outcome. First of all, let's go and run it. Okay, sorry, I forgot to use semicolon rather. Okay, so let's go and run this program. Okay, nice one. After compiling and executing this program, we can see that the size of array 10 okay, so that is that. We saw that the array size of 10, we assign I to an increasing value of 100. So that is the location to I plus 100, and then whereby I is also less than the array size, which is equal to 10. So 100 will be increasing by I, which is 1, 2, 3, 4, 5, 6, 7. So 100 will be increasing by I. That is why we had this number. So that is that for array initialization. Okay, now let's build another program, using a double dimensional array. So new project, console application, array, double dimensional. Okay, so array dd. Okay, let's use the source code. So this array would show 5 Okay, so let's build an array which will show 5 rows and 2 columns. So this program shows array with 5 rows and 2 columns. Okay, so let's include a standard input output. Then our main. Okay, so over here let's assign integer values a with a size of 5, and then with another size 2. The first one is for the row, and then the second size is for the column. So let's display their various elements. So we have 0 and 0. So we have 0 and 0. We have 1 and 2. We have 2 and 4. We have 3 and 6. And then we also have 4 and 8. Okay. Alright. So what we are going to do is we will assign 2 integer values, say I and j. Okay. So we will use a loop to initialize each of them. So for I is equal to 0, I is less than 5, which is the array size for the first element or the column, and then I plus plus. Okay, so with this for j, another loop inside I. For j is equal to 0, j is less than 2, and then j plus plus. Okay, j plus plus. So let's print the variables or the elements the various element for I and j inside A, so percentage D, and then percentage D for the other element, and then is equal to percentage D all with respect to I and J, so I, J, and then the array size I, and then J. Okay, so that is that. That is that. So this is an end of inner loop, and then this is end of outer loop. Okay, so let's compile and execute this. Okay, we can see that we have been able to store all the variables that we have, or the element for the first array, and then we have been able to also store the second array. So when we compile and execute, this is the result that we get. So that is that for double dimensional array. Hi, in this topic we are going to learn something about pointers. A pointer is a variable whose value is the address of another variable. We can say a pointer stores a variable in another variable, or simply put, it is the address of another variable. So for instance, when we have, and then a pointer is denoted by the star notation. So for instance, when we have int star ip, it is a pointer to an integer, and then when you have double, which is denoted by star dp, it's also a pointer to a double. When we have a float variable, the pointer will be star fp, which is a pointer to a float variable, and then we have char cp, which is also a pointer to a character variable. So now let's build a program, to support pointers. So over here, let's open a new project. Console application. Select C, and then let's give this project title pointer. Okay. Okay, so we have our main.c source code already. So let's build a simple program for pointer. So let's include stdio header file, main function, braces. So let's declare some variables. So integer var is equal to 20, and then integer star or pointer IP, which is a pointer variable declaration, and so IP is equal to address of var. Over here we are storing the address of variable into the pointer, which is 20. So we are storing this 20 into the address of the pointer. So let's, over here we are storing address of variable into pointer variable. Okay, so let's print address of variable is the percentage of x this is addressing to the var, it's addressing to the variable. Okay, so now let's store the address, or let's address it into the pointer variable. So let's print address stored in pointer address stored in IP variable, address stored in IP variable address stored in IP variable is also percentage x percentage x also with respect or addressing to a pointer IP. Okay, so over here what we did was we stored address stored in pointer, address stored in pointer variable. Okay, and so let's access the values. Let's access the values using the pointer that we have. So let's access the values by using the printf. So values of pointer IP variable is also percentage %d address to the pointer IP. Okay. Over here, accessing the values using the pointer. Pointer. Okay. So finally, let's return 0, and then let's go and run this program by compiling it and see the outcome. Okay, so when compiled and executed, it produces this result. So the address or the storage location is 28FFB, and then address in IP variable is 288FFB, and the value of the pointed variable is 20, which is the 20 that we assigned over here. Okay, so this is it for pointers. Let's build another program. Okay, now let's build another program to access pointer into an array. So let's include standard input, output, header file, and so we will be assigning a constant integer for max, which is equal to 3. Remember, this is a global variable. So int main, where our main function will be beginning, and so let's declare a variable array. Declare a variable array with element 10, 100, and 1000. Okay, so let's assign an integer I and pointer ptr. Okay, so what we are going to do is, let us have array address in a pointer. So we have ptr is equal to variable. Okay, So for I is equal to 0, and then I is less than max. Okay, so let's find I increasing value. So let's print if the address of variable of array is percentage d. Percentage d, which is equal to the percentage x with respect to I and ptr, respect to the pointer. Okay, so and then ptr increasing value. Okay, so let's return 0, and then so we assigned a constant integer max, which is equal to 3, and then our main function began. So we assigned an array of variable with an element of 10, 100,000, and then we have an address in the pointer which is equal to ptr is equal to variable. So we use a loop over here for I is equal to 0, and then I is less than max. So I increasing value, then we will be printing the address of the variable and then the storage location or the pointer. So let's compile and execute this program and see. I'm sorry, I have animations somewhere here. I have animation. Okay. I have animation. Okay, so I expected identifier before the token. Okay. Okay. Expected identifier before the pointer. Okay. So instead of comma, I didn't made it full stop. So let's compile and execute it and see. Okay. So it has been compiled and then produce us with this result. So address of var 0 is A, address of var 1 is 64, address of var 2 is 3A. So that is that for pointer to an array. Okay. Hi, in this section we are going to learn something about strings. In C programming language, a string is actually a one-dimensional array of characters which is being terminated by a null character denoted by /O. Thus, a null terminated string contains the characters that comprises the string followed by a null. So for instance, when you are creating an array of strings for the character hello, we have a size of 6 array. So let's count them and see. We have 1, 2, 3, 4, 5, and then 6. This is the null terminator which is terminating for this string. So let's build a program and then see how strings are being, running the compiler. So let's create a new project, console application. Strings. Okay, so first of all, let's include header file stdio, our main function. Then let's assign char value greeting with an array size of 6, which is equal to braces with single quote, and then our null terminator. Okay, always remember to bring your semicolon. Without it, your program cannot be run. So let's print F to greeting message. Greeting message percentage S, and then with respect to greeting. Let's return 0. Okay, so let's go and run this program. Okay, so we have a greeting message hello. It has printed a string for me. Okay, now more on strings. Let's write a program that would swap, or that would copy string into another string, that copies string into another string. Okay, let's include stdio header file. This time around, let's include string because we'll be using manipulators which are found in the string header file. So let's okay, so our main function begins. Let's call our braces by assigning car value of a which is equal to car value of an array a which is equal to let's type maybe Swati is an artist. Swati is an artist. And then another can be for which we don't know, so let's put an array size of maybe 50. Okay, so let's use strcpy, which is a header file that will copy A into B. I would copy A into B. So let's print the target string is equal to %s with respect to B. So over here we are putting A into B. We are putting A into B, or we are putting B into A, B into A. Okay, so let's go and run this program and see. Okay, the target string is equal to Swati is an artist. So this manipulator helps to copy, one string into another string. Okay, now let's build another program. Program that prints reverse of a string. String. Okay, so let's include a string header file. Okay, so let's print str string, which is equal to Sparty, which is a name of an artist. And then let's use the manipulator stref bracket str. We are printing the reverse of this str, which is the string. So puts str. Str. So over here it would print, puts str or print the same as printing strings, printing the strings. So it's the same thing, the same as printing a string. So let's go and run this program. Okay, so we can see that it has printed this thing in a reverse form. So that is that as far as string is concerned. Hi, in this section we are going to learn something about input and output function. This is the process of feeding data to the computer and displaying them to the user. In C programming, we have inbuilt functions that perform such tasks. We have the standard files, which contain the standard input, standard output, standard error. Standard input can be accessed by stdin, which is being done by inputting it using the keyboard. And then we also have the standard output accessed by stdout, which displays the inputted data on the screen. And then we have standard error with stderr, and then it also displays the error on the screen. We also have getChar and putChar. With getChar, it reads the next available character from the screen and returns it as an integer. And then with putChar, it passes the character on the screen and returns it. We also have the scanf and printf that we've been using throughout the program. And then what they do is, with scanf, it waits for the user to input a text, and then the printf displays it on the screen. So let's build a simple program, to conform with what we have learned over here. So let's open our code block. Okay, so let's open a new project. And let's give this project title input output. Okay, alright. Okay, so with input output, let's okay, so let's include std standard header file, and then let's write our function. Let's assign an integer, say a, and then let's print enter a value. Enter a value. Okay. So a is equal to get car. Okay, a is equal to get car. Okay, so print f you entered you entered semicolon, and then let's use put car also. Okay, and then let's put a into put car, semicolon. Okay, so let's return 0 finally. Okay, so over here let's run this program. Okay, let's rebuild it. Okay, it says enter a value, so let me enter maybe 3. So he said you entered 3. Okay, fine. Let me enter my name. Okay, Derek, and then I press enter. Okay, you can see that when we compile and executed, it waits for us to input a text, and after pressing enter, the text was displayed. But over here, the put car only read the single character, which is the D, thereby omitting all these characters. So what the put car does is it reads only a single character and then display it. So that is that for input and output characters. Okay. Hi, in this topic we are going to learn something about typecasting. This is a way of converting a variable from one data type to another data type. For instance, when we have a class size of 4 and then out of the 4 their total marks is 21, or the sum of their marks is 21, and then we want to find the average. Now what will happen is that we first have to convert this sum into double. We have to convert this sum here into double. so that we can easily divide it. Since this is data type is an integer, we have to convert it to double so that we can divide it and then have our double mean or average. So this process. Okay, now let's open our code blocks, create a new project, console application. We click next, we select C, then next let's give this project title typecasting. Okay, then we click on next. I have a project named typecasting already, so I want to overwrite it. Then we click finish. So we click on the source main, and then we have our default main function over here. So let's clean them and then start to build a new one. So first of all, we have to include our stdio.h, which is the header file, and then our function in here. Oh, sorry. Then our braces. So int sum is equal to 21. Our size is equal to 4. Let's call our semicolon, and then double mean also we are calling these variables as well. So now double mean or mean is equal to double sum. This is because we want to convert sum, or we want to typecast sum into a double value or variable, so that our outcome or the answer will yield a double variable. So our mean is equal to double sum divided by size. So now let's print the value of mean is equal to the percentage float with respect to the mean. So remember always to bring your semicolon, and then let's build and run this program and see the outcome. Okay, very good, very good. Now we can see that after compilation, the value of sum is first converted to type of the double and then gets divided before it produces the answer or the value. So we can see that this value of sum over here, the 21, will first have to be converted into a double value. Here 21 here is an integer, so it has to be converted into a double value before it gets divided by this, in order to provide or they produce the mean or the average value. So this is how typecasting is. Hi, hi. In this topic, we are going to learn something about recursion. Recursion is a process of repeating an item or variable by itself, repeating it over and over and over and over. That's a recursion or a recursive call. So now let's open our code blocks and then take a good look at how recursion also do operate. So let's click on new project and then console application. We click next, see, then let's give this project title recursion. Sorry. Okay, we click next and then we click finish. So let's go to the source main and then we have our default program here. So let's give this a title of, or let's comment it as a recursive program. A recursive program. Okay, so now let's include a standard input and output function. Sorry, our header file, standard input output header file, and then let's call our main function. And then in the main function, let's print something like, let's print Spark console. Let's print Spark console. Okay. Then we call our semicolon. Sorry. Then we call another main over here, and then this main will be where the repetition or the recursive call will start. So let's give this as recursive call, and then let's close. Okay, we have already closed, so we have our braces over here, and then yeah, so this is a simple program to show the repetition of a variable. So now let's build and run this program and see how it will look like. Okay. So we can see that Spark console has repeated itself over and over and over and over and over and over. So this process of repeating itself over and over and over is called recursion. Okay. So this is how it's all about as far as recursion is concerned. Now, let's learn something about a variable. Variable is a name given to a storage area that our program can manipulate. It is also an entity which changes during execution of a program. For instance, we can have a variable char for character, integer, float, double for a double float, void, which means nothing is to be returned. Examples include integer, var, float y, char x. Now we have rules for declaring a variable, and then rule number 1 says you should not start a variable with a digit. You can't start a variable by naming it with a number. Also, keywords cannot be used as a variable. We learned keywords earlier. Examples which will include auto, float, Hi. In our previous lesson, we learned about data types. We also learned about the basic data types, the size or the bytes they occupy in a computer memory, and then their format specifiers. In this topic, we are going to learn something about variables, and we can see a variable is a name given to a storage area that a computer or program can manipulate. It is also an entity which changes during execution of a program. Now, with char, which is for all character values, we also have integers, int for all positive numbers, and then float for all decimal numbers, double for double, maybe a double float, and then void, which means nothing will be returned in a case of execution. So for instance, we can declare these variables: int var, also float y, and then char x when we are declaring variables. Now we have rules for declaring a variable. For instance, rule number 1 states that a variable should not start with a digit. You can't start a variable name with a number. 2. Keywords can't be used as a variable. We've learned about keywords already. Examples of keywords are auto, switch, static. All those keywords that we learned can be used. Hi, in this topic we are going to learn something about memory management. The C programming language provides several functions for memory allocation and management. The function can be found in the std library header file. Now, when we store a name of a person, we can have an array size, and then if we don't know the size, we can assign it to a maximum of 100 characters, thereby getting the car name and then the array size. But in instances whereby we do not know the length or the size of the car we want to store, we can use dynamic memory location. So let's build a simple program, so that we can understand what we are talking about. So I have a program here. Let's take a look at it. Okay, now this program is helping us to add some basic elements. So a program that calculates the sum, that calculates the sum of numbers entered by the user. Okay, so now over here we will include our stdio header file, and then memory allocations, they are also stored in the std library, so we also included std library and our function over here. So over here we assign some set of integer values. We assign n, and then I, a pointer, and then a sum which has been equated to 0. Okay, so for instance, the n over here is representing the number of elements that the person wants to add, or the number of numbers to be added, that is n. Okay, so now the pointer ptr is equal to the integer, and then the memory allocation n times the size of over here is referring to the size of the integer value. So over here we assign an argument that if ptr is equal to now, then it means it will print error, memory not allocated, and then when you type 0 it will exit it. Okay, also when you enter the element, you're using a for loop over here, and then if the for loop I is equal to 0, I has been equated to 0, so therefore I is less than n, and then the plus plus of I. Okay, so what we would assign over here will stand for the pointer, and then add it to I. Okay, so therefore sum plus is equal to the pointer of ptr plus I, and so what we get becomes our sum. Okay, so let's run this program and see. Let's compile it. Okay, so let's maybe enter a zero element, an element which doesn't have any numbers in it. So let's press enter and see. Okay, we can see that enter an element, the sum is equal to 0. The sum is equal to 0 because over here sum was already assigned or equated to 0. That is why we had 0 over here as we type the element 0. Okay, now so let's compile again, and then okay, so let me enter 4 elements. That means we are adding 4 different numbers. So the first number is 2, the second number is 7, the third number is 3, and then our last number, supposing it is also 3. Okay, so you see it summed them up, and then the answer became 15 because 3 plus 3 will be 6, plus 7 will be 13, and then plus 2 here, which is our first element, it will become 15. So it's as simple as that. So that is that for memory allocation. Hi, in this section we are going to learn something about memory management. Now, the C language programming provides several functions for memory allocation and management. The functions can be found in the std library, which is a header file. So when we want to allocate a memory dynamically, we have dynamic memory location. When we store a name of a person, we can have an array maximum size of 100 characters, thereby getting something like let me explain this over here. You see, what we learned in array was when we are storing a name for a person, we can have an array size. For instance, we can have an array size of 10, 5, but the maximum size of an array we can have will be 100. So for instance, when we want to write or want to store an array, or in a situation whereby the length or the size of the car we want to store, we cannot know. For instance, if we don't know the size of the array, we can even write something like car and then hi. In this topic, we are going to learn something about command line argument. It's a programming through DOS prompt of a PC. Thus, it's a programming through the disk operating system of a PC. When we want to pass some values to a C program, when executed, it can be done through the command line. And then let's go to the steps for starting up the command prompt. First of all, you click the start button, and then you type run in the search, and then open it, type cmd and press enter, and then command prompt windows will start. Then type the command to be executed in the field, thereby knowing the location or the directory where your program that you want to get executed has been stored, and then that is it. So let's do the small program to pass some argument into the command line argument. So let's include let's give the program a title. So this program, a program to check argument supplied from the user, from the command line. Okay, so let's include a stdio header file. Okay, then our main function. Okay, so let's assign some values in here, right? Argument C, and then a car pointer, sorry, car pointer to an array. Okay, sorry. Okay, okay, now so let's call our brace and then pass some argument. If arg C is equal to maybe 2, then let's print the argument provided is, let's print the argument provided is %s for string. And then it's a car value for the pointer and 1. Okay, else let's use else if here. Else if the arg C is greater than 2, let's print too many arguments supplied. Too many arguments supplied. Okay, and then let's use else. Let's print 1 argument is expected. That is when the string provided or the character provided is less than 2. It's less than 2. Okay. So let's run this program and see the outcome. Okay. So our command line has been, compiled and executed. So that is that.